Hello and welcome. This is Ahmed from Ain Shams University. Today I'm going to give you a quick overview about our project, which is design and control and manufacturing of an autonomous underwater vehicle, and a little bit of information about the product that was given to us by Teledyne, which is Pathfinder DVL, and how it would contribute to our research endeavors. So let's start. First, I'd like to talk about our institution, which is the Faculty of Engineering, Ain Shams University. Ain Shams University was founded as the third Egyptian university. It was first comprised of some separate entities or faculties, including the Faculty of Engineering, which is a faculty, before they were combined into a singular university. Ain Shams University was founded in 1950 under the name of Ibrahim Pasha University. The name changed later to Ain Shams, which means, which is the Arabic translation of Heliopolis, which is the city of the sun, an ancient name for a city in ancient Egypt. Since 2011, the faculty began to participate in several activities and several competitions, including Formula Student UK, Shell Eco Marathon, Made ROV, lately Robosub competition for autonomous underwater vehicles. So our team's name is ASmarine. AS, of course, refers to Ain Shams. ASmarine was founded in 2019 with me as its head. The team focuses mainly on hands-on implementation of academic knowledge in order to create and create our products and manage our projects. There are both technical and managerial aspects to our projects. Each are handled by separate teams, each specialized in a certain field, whether technical or managerial. Also, we hope to shape the marine industrial revolution, something that we refer to as an industrial revolution that's going to affect the marine aspects or the marine resources of the planet and help us avoid major global problems or assess these problems and help solve them through the use of robotics and marine science to better utilize our planet's resources and eliminate the causes of pollution. So about the Pathfinder DVL, the Pathfinder DVL can offer some velocity and odometry estimates for our vehicle through its bottom tracking capabilities. These odometry and velocity information are then fed to the computer of the vehicle, which fuses this data with raw sensor data from other sensors in order to produce some accurate and precise estimation of the vehicle state and localize the vehicle and draw a map of the environment underwater, which is basically the main functions of a navigational system for an autonomous underwater vehicle. The Pathfinder DVL has excellent properties. It can provide very accurate and very precise odometry and velocity estimation data. I think the error of velocity estimation might reach some millimeters per second, which is, in our case, is very negligible. So some details about our project. Our project mainly is named Design of a Low-Cost, Computationally Efficient AOV Navigation System. So we're talking about the trade-off between computational complexity and cost, while trying to maintain the best possible accuracy underwater. So the motivation for our work is that most industrial AOV navigation systems rely on insanely expensive sets of hardware. So we're trying to create a cheap navigation system, which is also very accurate and precise and can compete against more complicated and more sophisticated, and most importantly, higher cost similar systems. Our project is comprised of several domains, including perception, which is the processing of sensory data, whether they are visual, like using a stereo camera, for example, or whether they're related to odometry, like IMUs, or rotation, also IMUs. Localization and mapping, which is tackled in our SLAM module, simultaneous localization and mapping module. And last but not least, the control of the vehicle to achieve the trajectories that are determined by the path planner or the mission planner. So our project milestones include the selection of the specific group of sensors that we're going to use for the project, and provide a reasonable cost analysis of the sensors and the electronics that we're going to use in the project. And the second milestone is the development of the correction algorithms that will be used to better enhance our sensory perception of the underwater environment. Also, we aim at creating a very efficient and robust dynamic model of the vehicle that's going to help us in both the control project and the estimation of the vehicle states, since prediction is a very important step in our SLAM module. And we also need to design and implement an efficient simultaneous localization and mapping module and an obstacle avoidance algorithm to locate the vehicle in the marine landscape that we're dealing with, whether it's sea or an ocean, or even it doesn't have to be marine. We might test the vehicle in a lake, for example, like the Transtic Lake or a simple chlorinated pool. Also, we need to design and implement a novel multi-controller architecture controller that is going to be very computationally efficient and able to achieve and follow the trajectory, the trajectories that the path planner is going to feed to the vehicle. Also, we need, of course, the mechanical and electrical design of the prototype AOV that we're going to use to validate our results. Finally, we have the project simulation and proof of concept, and also the testing or the actual physical testing of the vehicle and the validation of the results of the simulation. So what we hope to learn for the 2020 season and the possible outcomes that we might reach is how to simulate such a vehicle underwater, and how to predict the behavior of the vehicle and offer a complete project simulation. Also, how to validate these results and how to offer practical proof of the efficiency of our system. We also need to document the whole aspects of our project for future generations, and we need to publish some research papers, because this is a crucial part of the team's contribution to academia. Also, we need to set the stage for some future plans regarding future versions of our navigation system that are going to be more precise and more accurate than the current one. So it's a process of continuous development and evolution. So that's all. I hope you contact me if you have any questions. You can use my email provided here, 7answer1994 at gmail.com. Finally, I'd like to thank Teledyne for its contribution to our project, and I'd like to encourage the staff of Teledyne to continue their awesome work on their sophisticated and robust equipment. Hopefully, we're going to deploy more of these equipment over the years, and hopefully our partnership might extend to future projects as well. Thank you very much. Have a good day.